We are now live. Okay? So we're going to start on chapter 20 here. Now I'm hoping you guys are going to get, in one sense, you're going to think this class is really repetitive because you're going to know all the test questions. Not all of them, but most of them. The question is, do you know the answer? Okay? So in chapter 20, we're going to be testing a mean with sigma is unknown. But it could be known or unknown. Chapter 20 is going to deal mostly with unknowns, sigma. Okay? So we're going to cover what we call the student T distribution. Okay? It was discovered by a guy named William Gossett. Okay? He was an Irishman. And oh, by the way, just a good piece of trivial pursuit here. He used to work for a beer company. Okay? So, yeah, this came from beer, basically. So what happened was he didn't put his name on it. He just called himself Student T, and that's how it got its name when he was publishing. So Student T is William Gossett. Okay? Now let's talk about some rules first of all. Number one, sample must come from a simple random sample. Okay? So that's part of the reason why I asked you guys on your projects to make sure that you can do a simple random sample. Okay? There are some where we're not going to have a simple random sample. I'm going to say do it anyway, but note that you're breaking the rule when you do that. Okay? Number two, it must be independent. Okay? Now, let's just mention that really quickly. I know you guys have two choices for your final project. You can either weigh some potatoes or you can check some speed limits. Okay? Now, let me just mention here, if you're doing the potato bags, okay, don't go to one store and check all of the bags because we can't say that those are independent anymore. That's what it is at one store. Okay? So make sure if that's what you're going to do, that you're going to go to multiple stores. Okay? Smith's, Albertsons, Fresh Market, whatever, and find those because we want those to be independent. Okay? One store is dependent on that one store. So we want to make sure it's independent. Number three, data should be normally distributed. Now remember, just because let me throw this out here. Number four, your n should be greater than or equal to 30. Number five, there should be no outliers. Okay? Now, remember, 30 is not a magic number. Don't say, we got 30 is automatically normally distributed. How do you verify something is normally distributed? I'll speak at once.
What was your question again?
How do you verify that your data are normally distributed?
By making a graph.
Which graph?
Bell curve.
The bell curve. What's that called?
68, 99, 95.
What's the name of the graph?
That's histogram.
A histogram. Thank you, Porter. Who studied with Porter?
I wouldn't study.
Porter got that answer right. Okay? So make sure on your final projects, what are you making? Histogram. Very, very good. All right. So remember, just because something's 30 doesn't mean, we're going to assume, I'm not going to make you guys draw histograms on all the homework because I want to cover the new test, but make sure that your data are normal. It's just because you collected it doesn't mean it's normal. Okay? All right. Okay, so what I would like to do is, let's do an example here, okay? Now, do you guys remember all 7 steps?
I know our numbers.
Okay, that's one of them. Do you remember also, like if I gave you a quiz on Monday and said list the 7 steps, could you list them?
No.
Yes.
So by Monday, could you list them?
Yeah. I could try.
Okay,
Really try.
maybe I'll make that my quiz on Monday. That'll be a good quiz, right? Do you know the 7 steps? Because we're gonna do those
But like,
every
all the
day,
stuff that you're gonna
pretty
be
much
about
for the
the
rest
seven
of the
steps.
class. We're gonna do that pretty much
All
every
the
day.
stuff that you wrote on the board are just like what they are.
I
like
wanna
the
know
ones
what
you
the
listed
7
on the
steps
quiz.
are. Okay?
Like how you listed.
We're gonna do an example here, and I'm gonna ask you guys, what are the 7 steps, and then you'll tell me, okay? As we do this problem, okay? So let's do an example. Or do I wanna cover one more thing? Actually, let me do one more thing, and then we'll do an example, okay? So you remember, we're gonna talk about the t-distribution, okay? Some of the things about the t-distribution. Number 1, it is symmetric about 0. Okay? Number 2, it has a thing called degrees of freedom equals your sample size n minus 1. Okay? Number 3, the shape changes based on your degrees of freedom, which I will abbreviate VF. Okay? Anything else there? Number 4, as your n increases, it looks more normal. And number 5, it has fatter tails than the Z distribution. Okay? So what I mean by that is, let's pretend that this is your normal distribution, right? This is your Z distribution. Normal distribution we refer to as our Z distribution, right? So if we were to draw a T distribution, it would look like this. The blue is the T distribution. Okay? Oh, I'm off camera already, but
What's that? Is that fun?
say it again.
What's that? That says fatter. Fatter?
Fatter. That's fatter tails. Okay?
I don't know what those look like. Fatter
They
tails.
both look like normal distribution. They're both bell curves essentially. But the T distribution has fatter tails than the Z distribution. Okay?
Wait, so fatter tails and Z?
Right. If the black is the Z, blue is the T. It's got fatter tails. Okay? It looks like the normal distribution, just that.
I don't
Okay.
see how Z.
You don't see what?
Where's the fatter tail part?
Well, this is your tails, right? These are your tails. So there's going to be more area in the T tails than in the Z tails.
Got it.
Got it. Okay?
Okay.
All right. So let's do an example here. Actually, I'll write the example here. Your example. Okay? The CDC, Centers for Disease Control, says that the mean cigarettes per day smoked by smokers is 18.1. We obtain a simple random sample of 40 retired smokers to see if they smoke less. Okay? Data results in a mean of 16.8 cigarettes per day and standard deviation of 4.7 cigarettes. Use alpha equal 0.10 to see if retired smokers smoke less. Okay? All right, so Cassidy, what's the first step?
List all important numbers.
List the important numbers.
Oh, 0.10.
What'd you say?
What did you say? 0.10. Return.
Use alpha equals 0.10 to see if retired smokers smoke less. Okay? All right, so Cassidy, what are the important numbers here?
Well, I'm still writing down everything, so if you just give me a few seconds.
Okay?
The standard deviation is 4.7
Which standard deviation is that?
of the sample.
So what letter do I use?
So, right now, that's population. S.
S, are you sure? Good, I'm glad you're confident.
Is it uppercase or lowercase?
It's usually lowercase.
Lowercase.
Okay? So you know what, you started at the end of the problem, let's start at the beginning of the problem. Okay? We're gonna go through every sentence. She says the mean cigarettes per day smoked by smokers is 18.1.
That's me.
That sounds like an important number. And you said it's mu equals 18.1. Why is it mu?
That's the population.
Because we think the CDC knows what they're talking about, right? We think the CDC says that's the population. We obtain a simple random sample of 40 retired smokers.
That's N. N equals
N equals
40.
40. Okay? To see if they smoke less, data results in a mean of 16.8 cigarettes per day.
That's X.
X bar, why is it X bar?
It's the sample.
Because it's from the sample mean, 16.8 cigarettes per day. Standard deviation of 4.7, which you already got. Use alpha equals 0.10. All right, we're finally using something that's not 0.05. Why do you think we're using an alpha of 0.10? You know why? Okay. So I'll tell you why. 40, do you think 40 is a very big sample?
No.
No, I mean, it's more than 30, right? Is it big enough?
Yes.
Okay, it's big enough, so we're gonna, technically we should be graphing our data, but we're gonna assume based on that it's big enough, right? 40 is bigger than 30, but 40 is still pretty small, right? 30 is the absolute smallest, and actually we might do an example if we have time, where we're gonna use less than 30, but we're gonna assume on this problem that it's normally distributed, okay? Step number 2 is what,
Do you have a
Allie?
standard deviation in there?
What'd you say?
Oh, okay.
Yeah, she said that first.
That's
All right, Allie, what's step number 2?
Find out if it's categorical or quantitative.
Categorical or quantitative? And the answer is
It's quantitative.
quantitative, right? Okay. Step number 3 is what, Dylan?
That would be your null and alternative.
Find the null, H sub 0, and the alternative, H sub A. Okay, can you find those?
Yes. So the null is okay. That's Are we using X bar this time?
You think it's X
Oh
bar?
wait, no, we can't do X bar now.
We can't use X bar, never mind, thank you. Why can't we use X bar, never? Because it has to be the population. So it's gotta be mu,
Mu equals 18.1,
18.1.
and then the alternative hypothesis is what is the retired smoker smoke less. Okay, so mu
We're trying to see if retired smokers smoke less. That's
mu
the
is less than.
mu is less than 18.1. Okay, who agrees with Dylan on that? 1, 2, 3, 4, 5, 6. Everybody agrees? Anybody disagree? Okay, good job, Dylan. Is this a one or a two-tailed test?
One tails, right?
It's going to be a one-tailed test because why?
Because we're just looking at the side that's less than.
Yeah, we're looking at the less than. That means it's a one-tailed test. How would we know if it was a two-tailed test?
It just says does not, is not equal to.
Does not equal to. I don't know why it rings every day at this time. I may never read the message either. Okay? Yeah. I'm trying to sell my mom's house. So it might be helpful, but it's probably a real estate agent that I don't want to talk to. You never know. All right, step number 4 is what, Porter?
We use the formula.
Pick the right test, right? And do you know which test we're supposed to pick? Test 4 is usually the hardest step.
So we know that it's quantitative.
We know that it's quantitative, so that eliminates down to 2, right?
But our sample mean is known.
So it's either a Z or a T test, right? How do we know?
The sample mean is
Sample mean?
known or unknown. So
Mean?
standard deviation.
Standard deviation. Do we know the population standard deviation? No, so therefore it is a
T-test.
T-test. Do you remember the equation for the T-test?
Yeah, it's T equals.
Okay,
It's X bar, so 16.8.
well, let's go with the X bar first.
Okay,
X bar
minus mu
minus mu
all over S
S
all over
Over.
the square root.
square root of n. And oh, by the way, do we know my degrees of freedom? Maybe we should include that up here. We'll do it now. Degrees of freedom are
And
n minus 1, and n is 40, so your degrees of freedom are 39 degrees of freedom. Okay? All right, so we'll do that now. All I need to worry about, at this point, there's only one distribution that has degrees of freedom. We're going to learn another distribution in a few weeks. It's going to have a different formula for our degrees of freedom, so just be prepared for that. Okay? All right, now you started to give me the numbers. X bar in this case is
16.8
16.8,
minus
Minus.
18.1
18.1,
all over 4.7
4.7 over
the square root of 40.
Okay? All right, so, well, I'm off the board. You guys are supposed to tell me that. Okay? Now people can see what's going on. Okay? All right, so now let's do our calculator here. I'm going to use my favorite calculator, which is Excel. Okay?
Do you want us to round these?
In Excel, no, just leave it as is. Okay? All right, so let's see if we can kind of see this on here. Okay, so here we go. I'll make this big. Okay, equals 16.8, no, 18.1. 18.1 minus, no, this is 16.8, I was right the first time. 16.8 minus 18.1, that's your numerator, equals your denominator, which is 4.7 divided by the square root of 40. Okay, we'll take our numerator, we're going to divide by our denominator, and we're going to get negative 1.74. That's my t-score, as opposed to a z-score. Okay, so I've got my t-score. Step number 5, Kara, is what? Find the p-value. Now, step number 5 is find the p-value. Now, we have 2 different methods, and I'm going to show you them both today. What are the 2 methods?
Chart
Say it again.
chart
Chart
and Excel.
or Excel. Now, one of the things that I think you're going to find today is Excel's probably going to be a little bit easier than the chart is going to be. Quiz on Monday is going to be on the chart though, okay? So that's why I gave you all the formula sheets so that you can look at that. So let's do the chart first. Okay, now before we do that, what's the question you might want to ask yourself at this point?
Is the Z-score given?
That's not the right question you're looking for. You want a hint?
Whether we're doing a TEL test or not?
Here's your hint.
What would you do?
What would Rick do?
Draw a picture.
Rick would draw a picture. What am I drawing a picture of? A histogram? No, kind of.
Over.
Well, technically, the Z is the bell curve, but yeah, it looks like that's a T distribution as opposed to a Z distribution, right? Clear as mud, right?
Yeah.
Okay.
Obviously.
Now that I've used this awesome equation here, what is the mean of my T curve?
63.
The beta here. No.
No,
Oh, no,
it's 0, right? I've converted it, since I used this, I've converted that to a Z-score of 0. Okay? I got a T-score of what?
Negative
I didn't write that on the board. It was
Point
negative 1.74, correct? Okay? So I'm over on the left side, negative 1.74. Do you think I want the area on the left or on the right?
we don't get there.
Well, we'll talk about that in a minute, but do I want the area in the tail or not in the tail?
You want your area to hit.
I want the area in the tail. I want the area to the left. Okay? I want to figure out what that p-value is, right? Okay? Now, let's look at our chart. So if you want to open up your things, I'm going to use Excel here for a moment, just to make it a little bit easier to see. Okay? But look at your t-table. Here we go. Okay, so I've got it up here. We're going to go to the t-distribution. Now, before we do that, look at your z-distribution for just a moment. The z-distribution tells you the area to the left, right? That's why I've got this blue shaded area here. If I look at the t-distribution, it gives me the area to the right. That's the green shaded area. Okay? So these tell you just the opposite. Okay? Now, also, notice here in column C, I've got your degrees of freedom. And across the top, this table is going to be a little bit harder to use than the Z probably. Across the top, I have all of my different alphas. Okay? Now, let me zoom in a little bit here. By the way, my table's better than the one in the book. The one in the book does not have 39 degrees of freedom, but I do. Okay? Now, let's say, for example, you get 34 degrees of freedom, and you're using the book. What do you round that to? 30. Okay? Let's say you get 35 degrees and you're using the book table. What do you round that to? 40. So you round it to the nearest number, whatever that is. Okay? All right, we've got 39 degrees of freedom. Okay? So we are looking at this line here.
Wait, sorry, one more time. How do you know there's 39?
How do we know there's 39 degrees of freedom?
We get n minus 1.
Degrees of freedom equals n minus 1 right here. My n is 40, so n minus 1 is 39. Okay? All right, so I'm looking at 39. Now, by the way, notice there are no negative numbers. Okay? I got a negative 1.74. Now, here's the cool thing. Rule number 1 here about the t-distribution is it's symmetric. Okay? We're going to do one that's not symmetric and you're not going to like it, but this one is symmetric, and that's a useful thing. We're going to ignore the negative for a moment. Okay? Don't ignore it on your paper though, because I'll mark you wrong if you ignore that negative. That's supposed to be negative. Okay? We're going to ignore the negative. And what we're going to do is we're going to look for 1.74 on this line. Where does 1.74 fit? 1.74 is in between those two numbers. Correct? Okay? Which means at the top of your table, your p-value is going to be in between those two numbers. So you're not going to get an exact value if you use the chart. okay? So what I'm saying here is, in fact, I'll write it over here. If you're using the chart, the best thing you can say is your p-value is in between 0.025 and 0.05, okay? If you use the computer, okay, if you were going to come up with a command for the t-distribution, what would you call it?
Yes.
T-distribution. Now, by the way, there's a bunch of different ones you can use. The ones that I would recommend is use t period dot dist. Okay? Now, let's look at this for a moment. What do you think 2t stands for?
Two tails.
Two tails. What do you think RT stands for?
Right tail.
Right tail. Are we doing a right tail test?
No.
No, we're doing a left tail test because I drew my picture, correct? So the other one is your left tail test. We're going to use t dot dist. Okay? T dot dist. What do you think I'm going to put in for my x?
0.05.
Nope.
And then give me 7.35.
The t score is what you said? Yeah, I'm going to put in my t score. They should have put a t instead of an x there, right? Comma, degrees of freedom, 39. And then it's going to ask if you're going to use the cumulative distribution function. Does anybody remember what that was? Okay, it was on the first test, so you've already forgotten, right? Okay, here's what I'm going to say. If all of the probabilities up to negative 1.74, almost always you're going to use true in this case, okay? So just remember true. Yes, I want the cumulative distribution function, and then go back and review what's the cumulative distribution function, okay? So in this case, I get an exact p-value of 0.044, which you will notice is in between 0.025 and 0.05. Correct? Now, let's remind ourselves the alpha in this case is 0.10. Question number 6 that you're supposed to answer is what? Abby?
What? Reject.
Rule number 6,
Reject.
reject or not. And the answer is?
We do.
We're comparing our p-value, which we got as 0.044. We're comparing that to our alpha of 0.10. Is my p-value lower than my alpha? Yes, so therefore I reject the null. The null said that there's no difference between retired smokers and regular smokers, correct? We've rejected that. What do we think about retired smokers as our conclusion? We've rejected our null hypothesis. We think our alternative hypothesis is true. We're answering the question, do retired smokers smoke less? Yes. There is evidence that retired smokers smoke less. Does that make sense? Okay. Now, I'd really like to do another one, but we're way out of time. So I'm going to do another example on Monday. The quiz Monday is either going to be on the t-test or maybe you know all the steps you haven't memorized yet. And I'll make your homework due on Wednesday. Because I know that this is new to you. And we'll spend probably another day on the t-test. Okay? Do another problem. Okay? The quiz Monday, are you ready for the t-test? Can you use the chart? Do you know the steps? Those are the two main things I want you to focus on. Okay? All right. See you all.